Hello. It's my pleasure to introduce you to this new series called Trends. My first guest today is Eva Rio from Tuxera. Hi, Eva.
Hi, Sabine.
To start with, I would like to ask you, for people who don't know Tuxera, what is it that you guys do?
So Tuxera is an embedded software company. We develop data storage software like file systems and networking software.
Like Kedab, you have customers in automotive and also industrial and medical segments. So what are the trends you are currently seeing in both markets?
Yeah, great question. One of the main things that we are seeing is the increasing amount of data that's being generated in these two industries that you mentioned, in automotive and in industrial markets. So OEMs and manufacturers are looking for ways to deal with all this data growth.
So I wonder, what are the implications for data storage?
In the industrial environments of today, there is a larger amount of data that needs to be stored and processed. In industrial applications, this data is gathered from controllers, from small footprint devices, from data loggers, and this results in often multiple small files that come from multiple data sources of different types. And the workloads for storage are quite heavy. There are also continuous, so there is a need for file systems that perform well under these scenarios, that can quickly access file metadata and that have allocation mechanisms that can help speed up how data is handled on the device. How is it written? How is it erased? How is it accessed? There is also resource constraints and difficulties for replacement if a part breaks. So industrial customers expect that their devices last over 20 years at least. So NAND flash memory, when we talk about the storage, it has a limited lifetime. Before you write data to the media, you need to erase it. So this causes the flash to wear out. And the OEM or the manufacturer wants to ensure that the storage hardware achieves its longest possible lifetime, right? So in this case, they should think of file systems that are engineered to write to the media only when it is required, and think of flash controllers that have wear leveling mechanisms. Industrial and IoT devices often use microcontrollers that require software with a very small footprint that don't put a huge load on the CPU or the memory. And these same devices need to perform real-time operations, right? This requires predictability, it requires determinisms. There are multiple tasks that are competing for system resources in this environment. So you need a file system that does not create bottlenecks for the rest of other processes. You should also be able to customize the software to fit the specific workload that you are trying to address. And file systems that are shipping together by default with the RTOS or with the operating system are not very customizable or flexible in this way. Yeah, very, very important when it comes to storage is fault tolerance and fail safety. Reliable and always consistent data is a key requirement of industrial applications. So if there is a power failure, OEMs will expect that there is no corruptions to the data and that they can rely on their integrity. But this is not always the case, unfortunately. And off-the-shelf standards file systems do not guarantee integrity of the data in the event of an unexpected power loss or an unplanned shutdown that can happen in a factory. One potential solution for ensuring critical data is never lost and that is saved is to use reliable transactional file systems where live data is never overwritten, or use file systems where fault tolerance is a key design of the architecture, for example. And fast recovery after shutdown is needed. So power failure in an industrial environment means not only that you may lose critical data, but the system needs to boot quickly, it needs to be operational as soon as possible, so every second counts. There are file systems that are able to keep the disk always in a known good state, so there is no need to replay a journal or to perform any checks even after a power failure or an unexpected shutdown. So these type of file systems are an advantage here.
Thank you so much for your insight. It seems that so many things need to be taken into account when dealing with data storage. How about we concentrate a bit more on the fail-safe aspect? Any tips on how to make software and technology more fail-safe? Is there a mistake that you see the most currently?
I think understanding what is meant by fail safety in a project is the first step here. So, are you talking about hardware reliability, system reliability, or data reliability? So then you know where to focus your efforts. There was a talk at KDAB also from one of my colleagues, Sami Kasimaki. I recommended you watch that as well. And the advice I would give is not to think of storage and data management too late in a project. It shouldn't be an afterthought. And understanding the lifetime of the project, calculating the cost of replacement and maintenance in the budget, that should also be considered.
Definitely, yes. I'll make sure to link to the talk you just referred to in the description underneath the video. So finally, what would you recommend application developers do in terms of file system usage, for example, regarding performances and reliability?
I think the key here is to understand how the device is going to be used, either by the manufacturer or in the field by a third party, by the end user. So there is a balance that needs to be achieved, as you said, between performance and reliability. And knowing the use cases and the requirements for the data and the workloads for the project is fundamental. And yeah, in case of doubt, if you think that data is critical for the operation of the device and for your business, as is most cases nowadays, and you can reach out to experts like us if needed.
Excellent. Well, thank you for your time. It was really nice talking to you and very enlightening. And I hope the audience will feel the same. If you have questions for Eva or for Tuxura, you can leave them as comments and they will get forwarded to Eva and her team. Thank you, Eva.
Thanks for having me here.
Bye.
Bye.